Hey guys, sorry that I couldn't be here. I figured I could record the lesson, so it was like I was here to teach you the material. Alright, so today we're going to learn about rotations on the coordinate plane. Before we begin, make sure that you, obviously, if you are seeing this, you have my video, but make sure you have the video as well as the guided notes. The guided notes are where they always are when I am in class with you, so you're going to go ahead, go to OneNote, open the Notes tab, find the one labeled 2.9, rotations on the coordinate plane. All right, and then what you're going to need to do is you're going to need to put this video of me going through the guided notes with you on one side, and you're going to put your notes on the other, so you can watch the video and follow along with your guided notes all at the same time. So if you do not know how to do that, I'm going to walk you through that process real quick. So you have a button on your screen. It is called the Windows button because it is the little window symbol, and the window symbol looks like a window. It looks just like that. I think it's a little bit more angled than I do it, but that should be enough to find it. It's next to the FN and the ALT button, the little window. So what you're going to do is you're going to hold down that Windows button. As long as you're holding down that button, you're going to hold down your button, and you're going to press left or right, whichever button you hit. This video is going to be on that half of the screen. So if you look, my left half is this video. And make sure you already had your guided notes open. What you're going to do, I'm going to open it full screen because you will not already have it split screen. However, I do. So you have your notes open. You're going to hold down that Windows button and go the opposite direction. The last time I put mine to the left, so I'm going to hold down my Windows button and push it to the right. Sometimes it does this and it says, well, we see that you split screen. Which one do you want to do? Even though you already split it. So then I'm going to say one more time, hey, no, I want this video on the left side. All right, so at this point, you should have the video on the left side and your notes on the right side. It should look something like mine. If your notes are open and they look funky like this, you have all these tabs. You can go ahead and hit this so that you can see now the full extent of your guided notes. Now I'm going to close the guided notes because my guided notes are in this smart notebook that you will follow along with me in the video. But you're going to follow along with me in my notes, and you should have your blank guided notes to fill out as we go in the OneNote. Okay, so let me open mine back up. All right, so today, now that we have our notes all set up, ready to go, our learning objective is that by the end of this lesson, you should be able to rotate an image around its origin. An image specifically on the coordinate plane around the origin. All right. So today we're going to talk about rotations on the coordinate plane. So a rotation is a turn of a figure around a fixed point called the center of rotation. Specifically today, we are going to be working on the coordinate plane, and if you know with our coordinate plane, that very center point is called our origin. That will be our center of rotation. We'll rotate in increments of 90, so remember your coordinate plane looks like this. Let me scroll up so that if you are writing as I'm talking.
This is our last call for both water.
Alright, so let me go ahead and put this coordinate plane up here. So if you have a coordinate plane, you know it looks something like that with your x and your y axes. So we have quadrant 1, start of your C, quadrant 2, continuing on, quadrant 3, and the end of your C is quadrant 4. So we have 1, 2, 3, and remember it's in Roman numerals, 4 being the end of your C. Each quadrant is a 90 degrees when we are rotating. So if I had a triangle and I rotated it counterclockwise, so I went this direction, each time I move it into a new quadrant and turn it, it will be 90 degrees. Let me rewrite this triangle so it looks like a triangle and not a blob. Alright, so here's your triangle. And when we turn it 90 degrees, it will look like that. And then you turn it again. So 90 and 90 make 180. And it's going to look like that. And then when you turn it again, another 90 degrees. 90 plus, sorry, not yet. Well, yeah, 90 plus the 180 we've already turned, make 270. And then if you went again, 360. Most people know, full circle, we've come all the way back to where we started. And we did 90 degrees each time we turned it into a new quadrant. So my example, we did counterclockwise because we went the opposite direction of the way a clock spins. If you look at the front at the clock in my classroom, there is the little red hand on the clock that spins clockwise. Goes in the order, around 1, 2, 3, 4, 5, all the way that direction is clockwise. And if you went against counter, the way a clock spins, you are going counterclockwise. So they can be turned either way, and each time you spin it, it will be another 90 degrees of rotation. All right, so we're going to look at a couple examples. We're going to talk about what it would be clockwise as well as counterclockwise. Recall that we talked about we have a pre-image and an image. The image has those little apostrophes read as, in this case, we have A, new point A, or new figure A because we have a pentagon. So our pre-image is the A without the apostrophes. So if I took A and it goes, why can't I draw? All right, there we go. So if I took A and it goes from quadrant 2, wants to let me write anywhere but here. All right, if we take it and it goes from quadrant 2 to quadrant 1, first off, we know that is clockwise because we are moving the direction. A clock spins going clockwise. And we have gone from quadrant 1 quadrant, in this case quadrant 2, to quadrant 1. From one quadrant to the next, that is a set of 90 degrees. So we have gone 90 degrees clockwise. But as we talked about, we could spin things 2 different directions. I can spin it to the right from 2 to 1, and that would be clockwise. But what if I spun it the other way? So I go here, that's 90 degrees. I go here, that's another 90 degrees. And if I go here, that's another 90 degrees. And 90, 90, and 90. 9 times 3 is 27. We have a grand total of 270 degrees clockwise. Each time it passed through one of those quadrants, we rotated it 90 degrees. So if we were counterclockwise, it would be 270 degrees. All right, I'll leave that. So I'm going to do one more, and then I'm going to let you try it yourself. And then we're going to talk about how they actually work on the coordinate plane. If you look, again, the little apostrophe means new. So our starting image is this triangle here in quadrant 4, triangle B. So if I wanted to go let's go clockwise because clockwise is first. We're going to go this way. Again, each quadrant, 90 degrees. Another 90 degrees makes 180. And another final 90 degrees. We have gone 270 degrees clockwise. And if you spun it as you went, it would look something like that. Let's see. Make sure I'm spinning it right. It would be this. And then you spun it again. And then if you spun it one more time, you would end up back at your image. Right. And then I want you, oh wait, I lied. I told you I'd do one more. Let me erase our clockwise. I'm going to go counterclockwise. I don't have to show you the mid images. Counterclockwise is from our pre-image to this image opposite direction that a clock would go. And we've gone from quadrant 4 back up to quadrant 1. We've passed through one quadrant, that is 90 degrees. All right. Go ahead, pause this and attempt 3. Okay, I'm going to go ahead and go, but if you didn't pause it, try it before you just watch this. All right. So clockwise, we have our pre-image. So we're going the direction a clock would go. You have one quadrant, two quadrants. You should have gotten 180 degrees. For each you went. And if you went counterclockwise, again, from quadrant 3 to quadrant 4, and then quadrant 4 to quadrant 1, you've passed through 2 quadrants. That is also 100. Both of those are 180 degrees. Either direction you go, you are passing through 2 quadrants. Beautiful. All right, so let's take a look at this on the coordinate plane and see what happens. All right, so go ahead. I want you to go ahead, take a moment, pause this, and I want you to fill in the chart. You know how to label your ordered pairs. Tell me where A, B, and C are. A, B, and C. And then go ahead and tell me where new A, new B, and new C, our image is. Go ahead, pause it. Label them. Beautiful. All right. So we are going to go ahead. I'm going to go ahead and fill it in because you should already fill it in. Go ahead and check your answers. So original A, remember it is left and right, X, Y, where X is left and right, and then Y is up and down. So A is 2 to the right and 3 up. So you have 2, 3. B goes 5 to the right and 8 up. So you have 5, 8. And I need to close my ordered pairs. All right, and then C goes 6 to the right and 1 up. So 6, 1. And then, before we go ahead and talk about what we think has happened, we're going to go ahead and look at our image. So our image being where it has moved to, A is 3 to the right and 2 down. So you should have had 3, negative 2. And then you have I'm sorry, lost my train of thought. Then for new B, you have 7 to the right and 5 down. So that is going to be, I take that back. There's no 8, but 8 to the right and then 5 down. So 8, negative 5. And then C, our new C, is going to be 1 to the right and 6 down. And you should have got that. If you didn't, the most common issues I see are sometimes we go up and down before left and right. We don't necessarily see the negative signs and it looks like it's part of that line. But those are the ordered pairs you should have had. Now it says describe the rotation of affected values in the ordered pair. So let's look at A versus new A, B versus new B, C versus new C, and see what we think happened. Because our numbers didn't change. So if I look at A, I have 2, and then I have 3.
Verse 19 is our test.
And that is our pre-image. And from our pre-image to our image, I have 3, negative 2. So first, right off the bat, I see I have X, Y, and then my Y and my X switched. It is, our ordered pair is still X, Y. It's left and right, up and down, but how to represent how they changed, Y and X switched. And you have the opposite of x. Remember, that does not mean negative x. It is the opposite of x. All right? And then, so the x, well, that's our algebraic rule. So let's talk about how it affected them. Because the rule is what we just talked about with our numbers. So we have the numbers, and x and y switch places, and the sign of the x split. And then describe how the rotation affected the values in the ordered pair. Well, the x and y values switched locations, and y became the opposite. So it's basically what we talked about algebraically, but in words. The x and y switched. And the sign of x. So in this case, x went from a positive 2 to a negative 2. But don't let that negative fool you. It doesn't mean it's always going to be negative. If I had negative 2, it would have switched to positive 2. It flipped from positive to negative. Or if I had a negative, it would flip from negative to positive. So that's our rule. And again, thinking back, if we went pre-image without the apostrophes, if I went clockwise, it is one quadrant down. So clockwise, it is 90 degrees. And if we went counterclockwise, we go one quadrant. So we go from our pre-image, we go one quadrant, and we go to, it doesn't want to let me write. Alright, so one quadrant, then we go another quadrant, so we're at 190. 180, and we go for a total of 3 quadrants, and we are at 270 degrees counterclockwise. Alright, we're going to go ahead and try one more example. See how it changes. So we have triangle ABC. Alright, again, one more time, I want you to go ahead and take a second, pause this video, and when you are pausing it, you are filling in the ordered pairs for the ABC in our pre-image. Again, image without the apostrophes is your pre-image. And then you are going to go ahead and label ABC in your image. So in our pre-image, you had A at 2, 3. You should have had B at 5, 8. And you should have had C at 6, 1. And then for your image, you had new A at negative 2, negative 3. You had new B at negative 5, negative 8. And you had new C at negative 6, negative 1. Alright, I want you to take a second. Look at those numbers. And what do we think happened with our X and our Y? Because our numbers We still have a bunch of, like an A, we still have 2 and 3, but something happened to them. We still have 5 and 8 for B, something happened to them, and we still have something for C, but something happened to them. What do we think happened? Got an answer? Alright, so if you said that A and B, you have XY, if XY stay in the same location, but they both switch signs, then you were correct. And if we wanted to figure out which direction, or not which direction, how many degrees they were rotated, again, here is our pre-image. We go one quadrant that is 90 and another one that is 180 degrees counterclockwise. And if we went clockwise the opposite direction, we go 1 square, 2 squares. So again, either direction, we're going 2 boxes or 2 quadrants each direction. We have 180 degrees. All right, I want you to go ahead and pause this and attempt to plot your pre-image, not plot them. Tell me the ordered pair of your pre-image for 6, of your image for 6, and tell me how many degrees you think it has moved clockwise as well as counterclockwise. And while you're at it, once you have that solved, go ahead and see if you can figure out what the rule is. How did X and Y change? Are you done? Go ahead, pause it. Solve it. All right, so at this point, you should have already paused the video. And so I'm gonna pause the video, and then you are going to check your pre-image image, because in 2 seconds it's gonna appear. All right, man, I can write so fast. Your pre-image, you should have had A at 0.23, B at 0.58, C at 0.61, and then your image, your rotated image at -0.32, at -0.85, and at -0.16. All right, so if we look at those points, we have, and you can just pick one point. We look at A has 2, 3, and then it goes from 2, 3 to -3, 2. Well, right off of the bat, my X and my Y switch. And my 3, which is my original Y, went from +3 to, and I don't know why I said they switched, but did not switch them. So we have XY, X, Y, and then what happened was we switched Y, Y went to the front, and Y switched signs. So we have the opposite of Y, X is the rule to describe our rotation. All right. And I already talked about this by accident, but who can remember? Because I said it. I said it in the beginning when I was showing you those degrees. What would happen if a figure was rotated at 360 degrees? How would you represent a rotation 360 degrees algebraically? All right. So if you remember, I already said it. If you said we would end up back where we started, the image would be in the same location, so your image would equal or be in the same location as your pre-image, then you were correct. And I said that in the beginning when I was showing you 90 degrees clockwise as well as clockwise. If you went 360 degrees, you are going to end back where you started. Your image will be in the exact same place. It will be equal to your pre-image. So we can represent that by saying XY starting and finishing would not change. All right, and then number 8 says point G is at -3, 9. We know that it was rotated clockwise to 9, 3. So we are going to go ahead and first we are going to describe the degrees of the rotation and write an algebraic rule to represent the rotation. So we have -3 So we have negative 3, 9, and when we transform it, we have 9, 3. So when we are trying to figure out our rule, think about which number switched signs. Did our x and y stay in the same place? So when we're writing the rule, we have x, y being our original point G. If I made my x and y change to match the way G changed to new G, what would that look like? All right, so did my numbers go 3, 9? No, they did not. So your rule should have looked where x, y, where y moved to the front and x moved to the back. And when x moved to the back, what happened? It's a sign switch. That's why I've been trying to stress to you guys. It is not always negative x. If you see, we went from negative to positive. It is not negative x. It is the opposite of x. So there is our rule. Alright, so we have point B at negative 3, 9. We have point B at negative 3, 9. I want you to try and come up with a rule. So if we had point B at negative 3, 9, and then it became 9, 3, think about, did x and y switch? What had a sign change or didn't have a sign change? Go ahead and come up with a rule to explain how negative 3 being x and 9 being y, what happened to them? Did they flip? Did the sign change? And how would we algebraically represent that rule? Pause it, take a minute, figure it out. Alright, so at this point you should go ahead and be checking. We have x, y, so x and y flip. And, well, they flipped. X went from negative to positive, so it's going to be y. And then it is opposite of x. Again, stress this is not negative x because we went from negative to positive. So it doesn't mean x has to be negative. It is the opposite of x. So we have algebraically written our rule, and if we wanted to describe the degrees of rotation from negative 3, 9 to 9, 3, go back and look. We moved 90 degrees clockwise, following the same rule that we did. So you could have said 90 degrees clockwise, which would also have been 270 counterclockwise. All right. All right, here is what I want you to do. 9 is very similar to 8. I want you to go ahead and look at point M and look at point new M. And I want you to go ahead and figure out how many degrees you think it has rotated. I would start by doing it like we did before. Algebraically figure out, did numbers switch? Did signs switch? What happened? And then you are going to match your rule that you have created with one of those rules in 4, 5, or 6 to help you determine what the degrees of rotation were. So go ahead and pause this and solve 9. All right, so by now you should have paused it and you would have seen with 6, 8 being our image, they switched and then the sign of y switched. So Y moved to the front and switched its sign, and X moved to the back. Which means that point M was rotated 90 degrees counterclockwise. Which would be 270 degrees clockwise. Because that would match up with problem 6, counterclockwise. Alright, so what I want you to do is go ahead and attempt 10 and 11. I am not going to work them out with you. I want to see what you know. I'm going to read through it and help you think through it, but I am not going to solve it. So 10 says triangle ABC has the coordinates shown below. Jamie will rotate the triangle rule using x, y. So you have x and then you have y. You are going to move y to the front and move x to the back. And when you move x to the back, make sure you switch the sign. You're going to do that for A, B, and C. And you should be able to use that rule to describe the possible degrees of direction of the rotation using 4, 5, and 6. And you only have to, you only have to give the coordinates of where A would go following that rule. And then I want you to do number 11. And this is just thinking about how it works. If I rotated an object, am I going to change the size of it ever? So will it sometimes stay the same size? Will it never stay the same size? Or will it always, when I rotate it, stay the same size? Think about orientation of a figure. We've been talking about this. We had an example yesterday where the triangle was slightly to the left. And then when we mirrored it, and I'm not going to be able to draw a very good mirror, it was pointed slightly to, I said that backwards. It was slightly to the right, and then when we mirrored it, it was slightly to the left. And it did not retain its orientation. So when I have a rotation, do I sometimes change the orientation? Do I always change the orientation? Or would I never change the orientation of that figure? And if I rotate an object, is that going to change the order of its vertices or its corners? I want you to go ahead and solve those. I will check those. And then I want you to go ahead, if you still have time, to go ahead and begin the classwork sheet. The sheet that goes with this is in the classwork of the OneNote, and it is labeled Rotations on the Coordinate Plane Classwork. And that is your assignment for today. When I get back, I'm going to go ahead and check that you filled in your guided notes. Make sure that you attempted 10 and 11. And as long as you have filled in your notes as well as attempted 10 and 11, I am using the answers for me. I'm not giving you an accuracy grade as much as I see that you made an attempt to figure out what those answers are based on the lesson that you have seen, and then you can go ahead and work on the classwork sheet in the guided section of your notebook. If you do not finish, you may go ahead and finish it for homework, but you should have enough time to finish it. All right, guys, bye.